all communication that involves sound, by definition, involves sound waves. The next activities explore the nature of sound waves, how they are produced and transmitted. Now, to help do that, I need a volunteer from the audience. Yes, Darnell, come on over. What we're going to do here, Darnell, is we're going to show how waves move through a substance. Okay? And this is just to demonstrate that sound waves are a wave of energy that moves through a substance. Okay? That's what we need to think about. In order for sound to happen, we need to have a substance. Now watch this. Okay, real simple demo. Okay? We can all see the wave travel. Now notice, the rope is moving up and down, but it isn't traveling this way. Okay? It's the same way that sound travels. When a sound is made, the atoms in the air bump into the next atoms next to them, and they transmit the energy that way. The actual molecules, or the atoms, don't travel, per se, through the air. It's the air molecules themselves bumping into each other. So the wave of energy moves, but the actual air doesn't. All right? It's just like a tidal wave. I live in Oregon, and we get tidal waves on the Oregon coast. They come sometimes all the way from Japan, but that water isn't from Japan. But the wave of energy is from Japan, okay? But the actual water is just the water that was right up our coast that hits us. Okay. Now, what I'd like to do, thank you, sir, is an activity that we've all done as kids. It's making a paper cup telephone. And to do that, I need some teachers. So come on down, teachers. This whole next packet involves 3 activities that talk to us about the nature of sound. And the first one is this paper cup activity. Okay, what you're going to do first off is to see if, in fact, these paper cups will work by experimenting with a baseline experiment. Okay? What I want you to do is, with your partners, get the cups and move out in the front of the floor space here and face each other and see if you can hear each other when you're talking to the cups. Okay? Now just whisper. Don't talk too loud. Set about 10 feet apart if you can. That's good. Now give it a try. Whisper into the cup and see if your partner can hear. Can you hear each other? No. All right. So what we're going to do here is connect these cups and make actual telephones. Give them a substance through which the sound can travel. Come on around. And what we're going to do here is make these paper cup telephones in a very simple way. We just poke a hole in the bottom of the cup. Put a string through it. Tie that string to a paper clip, and then do the same to the other telephone on the other end, and when you pull it tight, you've got yourself a telephone. Okay, fantastic. Okay, go ahead and move out and see if they work. Can you hear? Okay, try it the other way. Okay, you hear it? Got it? Got it? Does it work? Work okay? Everybody's working? Fantastic. Okay, now, yeah, Sam, what were you thinking?
If we could connect so that all 4 of us can talk.
And how are you thinking of doing that?
Wrapping our string around there.
Oh, that's a good idea. What you've got is a little mini network. Okay, first, yeah, see if that works. You 4 do it, and you 4 do it here. Okay. Excellent. We've got ourselves a little network. Is it working though? Okay. Talk a little bit louder. You might have to have a stronger sound signal because you've got more substance to travel through. I wonder if there would be a way for us to get one huge kind of big conference call with 8 different people going on at one time.
If we go under and wrap.
Let's try that. Maybe right around the center there or something.
Well, like if you come under 2? Just your top, and then the 4.
Excellent. Okay, oh, that was good. We've got a web of wires and webs. Wires and waves right here. Oh, that looks good. Now, who wants to talk?
I'll talk.
Okay, Roosevelt. Is it working? Can you hear anything, or is it faded?
I can hear.
So try it again.
Pull it tight.
Pull it tight. Oh, that's really important. Pull it tight.
I can read that.
Just barely? What are we getting? You heard what he said. So yours was strong, yours was weak, you're a little bit further away. How about everybody else?
I didn't know that you. I think it's short.
Okay.
If we rack again, would that make it stronger?
I don't know. Give it a try. Good idea. All right, now as you make your networks in your own classroom, I hope that you'll give kids a chance to experiment with them. Have them go around corners, have them grab a hold of the line and see how that affects the transmission of sound. Just to give you a little hint, anything that interferes with the vibration of the string or dampens that sound impulse at all will weaken, of course, the amount of sound that can travel.